In this video, we want to take a little bit of time to talk about some terminology that you'll hear throughout your trig course. On this screen, we're going to discuss what is called a standard position angle. So a standard position angle is always going to be plotted with its initial side along the positive portion of the x-axis. So when you plot an angle in standard position, you're always going to be plotting in the coordinate plane, and you're always going to start your angle along the positive stretch of the x-axis. And then if we're trying to plot a 120-degree angle in standard position, we're going to have the initial side along the x-axis. 90 degrees would be, just putting the terminal side or where the angle ends straight up along the positive y-axis. Well, if I'm going for 120 degrees, I need to go 30 degrees beyond 90 degrees. So a 120-degree angle would be what you see right here. It's also possible to plot a negative angle in standard position. You'll notice that whenever we plotted this positive angle, this first example, what we did is we went through the positive stretch of y values whenever we plotted that angle, right? This would be counterclockwise. So when you're plotting a positive angle, you're going to work counterclockwise around the circle. When you plot a negative angle, you're actually going to work clockwise around the circle. When you plot, I've always said it like this: when you plot a negative angle, you're starting on the positive x-axis, but because your angle is negative, you're going to go through your negative y values first. That means we're going to drop down from the x-axis and plot that negative angle in a very similar way. If I'm plotting negative 90, I would go straight to the negative y-axis, but because I'm trying to plot negative 120 here, I'm going to go 30 degrees past that spot. So standard position angle, you're always starting along the positive stretch of the x-axis, and then if it's a positive angle, you're moving counterclockwise around the circle. If it's a negative angle, you're moving clockwise around the circle. Positive angle, move through the positive y values first. Negative angle, move through the negative y values first. The other bit of terminology that we're going to talk about within this video is what's known as a coterminal angle. So it is possible to have multiple angles get plotted in the same spot in standard position. So if I'm trying to plot a standard position angle, let's say I'm trying to plot a 30-degree angle. So my 30-degree angle, I'm going to start with the positive stretch of the x-axis. Whoops, had my arrow pointing the wrong way there. Really wanted that to show up on top. Let me see if I can adjust that. There we go. And then if I'm plotting a 30-degree angle, this would be 90. Half of that would be 45. So I'm gonna go to something like this, right? So that would be my 30-degree angle. So I've got 30 degrees right here. The reason why it's possible to have another angle that has the same representation when it's plotted in standard position is this. If I'm going 360 degrees, positive 360 degrees, I'm moving counterclockwise around the circle to get back to here. What if I move 30 degrees beyond that? What if I'm trying to plot the angle 390 degrees? If I'm trying to plot this angle, 390 degrees, I'm going to move that 360 degrees around the circle counterclockwise since it's a positive angle. This would get me 360. I need to go 30 beyond that. This angle looks the same as the 30-degree angle we plotted a few minutes ago. What if I'm trying to plot the angle negative 330? So let me just get that over here. So if I'm trying to plot the angle negative 330 degrees, so I'm going to move the opposite direction around the circle. So I'm going to move through the negative y values first. Now I need to move negative 330 degrees. If I move negative 360, I'm back to the x-axis, right? Negative 360 would be one complete revolution around the circle in the clockwise direction, getting back to the x-axis. Well, I'm not trying to plot negative 360. I'm trying to plot negative 330. What that means is I'm going to be stopping 30 degrees short of the x-axis. So 30 degrees, 390 degrees, negative 330 degrees, they all look the same when we plot them in standard position. Any standard position angles that have the same terminal sides, so any standard position angles that look the same when you plot them, they're called coterminal angles, meaning they all end in the same spot. So in this sequence of examples here, we're asked to do several different things. We want to identify all angles that are coterminal with each angle. then find one positive angle and one negative angle that are coterminal with the angle. So in this case, it's a 45-degree angle. So what I'm going to do is I'm going to start by plotting that 45-degree angle. So you see I've got the positive x-axis as the initial side of the angle, and then I've got my 45-degree angle plotted up into the first quadrant there. It is a positive angle, which is why I'm working up from the x-axis, up through the positive y values first. What I personally would like to do in this situation is do the second task first and then think about that first task. Identify all angles that are coterminal with each angle. Let's do that second task first. Find one positive angle and one negative angle that are coterminal with this. So let's think about this. Well, if we think about what we did on the prior screen when we were talking about coterminal angles for the first time, if I start at the x-axis and I go 360 degrees, but then I move another 45 degrees, I'm going to be at the same position, right? So if I take 45 degrees and I add 360 degrees onto it, or you can reverse that, you can do the 360 degrees plus an additional 45, whatever is easier for you to think about, you end up at the same spot, and that's going to give you a positive angle that is coterminal with the given angle. So 360 plus 45 more would be 405 degrees. If we want a negative angle that is coterminal with this, let's think about it this way. If I'm going negative 360 degrees, that'll get me back to the x-axis. I need to stop 45 degrees short of moving clear around the circle back to the positive x-axis. So if I'm stopping 45 short of 360, I would do 360 minus 45. That'll give me 315. I'm going to make that angle negative so that I don't move clear back to the x-axis. I stop right here at the same place where I had my 45-degree angle plotted. So here's my positive angle that's coterminal with 45 degrees. Here's my negative angle that's coterminal with 45 degrees. Now, I talked about this to kind of provide the visualization. There's definitely a shortcut here, and you might have caught on to it based on what we did. If I just added 360 onto this angle, I end up with another positive angle that's coterminal with 45 degrees. If I subtract 360 from this angle, I end up with a negative angle that's coterminal with it. So here's the shortcut for identifying all angles that are coterminal with each angle. All we're going to do is we're going to take the original angle that we were specified that was specified for us at the beginning of this, and we're going to add 360 times n, as long as n is an integer. I should have specified that. I'm saying it verbally here. So if I add 360 times n, as long as n is an integer, I'm looking at an angle that's coterminal with 45 degrees. What that basically means is if I put a 5 in place of n, 45 plus 360 times 5, that would mean I'm starting here, and then I'm moving 5 times around this circle, and I'm ending at that same spot when I add 5 times 360 onto 45 degrees. So hopefully that makes pretty decent sense for you. We'll try to speed this next one up. So I'm going to start by plotting the angle 225 degrees. So I always like to think about, where I am in relation to 0, 90, 180, 360. Those are the nice angles that are easy to visualize. So I realized that this is a little bit above 180. How much above 180 is 225? So 180 would obviously be this straight line across the x-axis here. It looks like I'm moving 45 degrees past that, right? 180 plus 45 gives me 225. So we've plotted the standard position angle. If I want another angle that's positive that's coterminal with this, I just add 360 on to 225, and that's something you do on the calculator. If I want an angle that's negative that's coterminal with this, I'm going to subtract 360 from 225. Fire that in the calculator, and you get negative 135. If you want all angles that are coterminal with this, you're going to take the original angle and you're going to add on 360 degrees times n, as long as n is an integer. What this statement across the bottom right here means is you're starting at a 225-degree angle, right? That's what you see at the front of this. So you're starting right here. If you add 360 onto it once, you move once around that circle. 360 degrees from that point a second time, 360 degrees from that point a third time is always going to put you back at that same spot. Even if you move the opposite direction, if you move the negative direction 360, negative direction 360 a second time, negative direction 360 a third time, as long as you're starting at that 225-degree angle, as long as you take an integer multiple of 360 around in the positive direction or around in the negative direction, you're going to end up in that same spot and be coterminal with that angle. So the last type of example we want to try to squeeze into this video here is this type. So if each angle is in standard position, determine a coterminal angle that is between 0 and 360. So if you have an angle that's kind of ugly, an angle that's big, an angle that's really negative, we've got a big positive angle here, we've got a negative angle that's pretty far from 0 here. You will always be able to specify an angle that's between 0 and 360 degrees. We want to state the quadrant that the terminal side lies in. So here's how I am going to start this. I'm going to start this visually by trying to plot this angle. So I realize 775 is way above 360. If I start at my x-axis, and this is a positive angle, so I'm going to move through my positive y values first. If I do positive 360 around that circle, that'll bring me back to this spot. Now, can I move 360 again from this spot and still stay beneath this value? And I think what you're going to realize is, yeah, you can. If you double 360, and you can double check this on a calculator, if you double 360, you get 720. So if I do 2 complete trips around this circle, I get back to the x-axis here. If I do 2 complete trips around the circle, I've moved 720 degrees. How much further do I have to move to end at 775? Well, I've already moved 720, so if I take 720 off of 775, I've got to move 55 more. 55 degrees is a little bit more than half of 90 degrees, so that's why you see I've plotted the angle that I've shown right here. So I've got my standard position angle, and the angle that's between 0 and 360 in standard position that's coterminal with this angle is that 55-degree angle. And then obviously this angle is in quadrant 1, right? We've got quadrant 1, then quadrant 2, then quadrant 3, then quadrant 4. So we've got a 55-degree angle that's coterminal with this angle when it's plotted in standard position, and that angle lies in quadrant 1. So in the last example that we're going to try to do within this video, we're going to try to do the same thing with the angle negative 1297. I'm going to take a similar strategy. I'm going to start on the x-axis. Now I am plotting a negative angle here, so I know I'm going to be going through the negative y values first. So if I go, and you saw me take 1 trip around the circle there, if I go negative 360, that takes me back to here. If I go negative 720, that takes me back to the same spot again. I still have a lot more space to go, right? I've got to go negative 1297 total. So taking 2 trips around the circle in the negative direction is just negative 720. I think I've got another 360 to work with here. If you do 3 times 360, that's 1080. So if I do 3 trips around the circle in the negative direction, that will be negative 1080 degrees traveled total. Now I don't think I have another 360 available for me to go. So I'm now going to have to kind of break it down in a little bit more detail. So if I've gone 1080, which is 3 trips around the circle in the negative direction, how much further do I have to go to get to 1297 total? Well, if I just take a quick 1297 and subtract off the 1080 I've already gone, what I end up with is 217. So let's see, I've done 3 trips around the circle. I'm back to this spot. And now from this spot, I have to go 217 degrees in the negative direction around the circle. Well, if I go 180 of those 217 degrees, I'm to this spot right here. Now, how much space is left to go? If I take 217 minus the 180 that I've just gone, I've got 37 degrees more to cover right here. Now, here's the thing. I am not going to give 37 degrees as the angle that's between 0 and 360 that's coterminal with this angle, right? This is not an angle that's being measured from the positive x-axis. This angle here is the angle that I'm going to have to give that's the answer for the first part of this problem. So now I'm going to have to think, all right, well, if I'm trying to specify this angle, I used this 37-degree angle to help me plot the angle that I started with in standard position. You should realize that across the x-axis here is 180 degrees. We have to do 180 minus 37 to figure out what remains right here, right? the angle that I have over here in red and the angle 37 degrees that's over here that helped us plot the standard position angle, they're supplementary, right? They sum to 180. So if I just took 180 minus that 37 degrees, and you see the answer there already, but if I take that 180 minus 37 degrees, that gives me that 143-degree angle that sits right here. So there's my answer for the first part of this, right? We've got a coterminal angle with the negative 1297-degree angle. That's between 0 and 360. It's 143 degrees. And the quadrant that that angle lies in is quadrant 2. So hopefully this has given you some practice and some understanding with what it means to plot an angle in standard position, what it means to find coterminal angles. Uh, it's a little bit weird whenever you have multiple ways to represent a single angle, but hopefully this has given you a little bit of an idea as to how you can visualize it and do some of the calculations that you may find helpful.